All right, guys. So I know this is a very hefty lab. So in this video, just gonna go over the tutorial. So for the first part, we were gonna use Autodesk Infoworks. We're gonna go ahead and build our model. So we kind of wanted this intersection between the Brazos River and Highway 60. So we're gonna go ahead and build our model here. Draw a rectangle. Doesn't have to be anything too fancy or too big. I kind of just wanted you guys to have this cross-sectional area here. Let's go ahead and give it a name. This is my third time making this video, so I'm making it HECRAS 3. So keep in mind our coordinate system is that we're using gonna be Texas 83 Central Zone US foot. Let's go ahead and select that. Create our model. Right, and so it's going to take a couple minutes for it to actually upload and whatnot. So while we're doing that, we're going to hop into Civil 3D. All right, just like how we would with any project, we're going to go ahead and go into our drawing settings and set our coordinate system up. All right, set our geolocation. All right, now we come back and we see that our model's ready to go. Gonna go ahead and open it up. It's gonna ask us if we want it local. Gonna go ahead and save it as a local file. All right, we see that our model's built. Gonna go ahead and go back to Infoworks. Gonna go ahead and see this is our local directory here. All right, now once we're done there, we can go ahead and close out of Infoworks. Hit the Infoworks tab, open model. All right, we're gonna search for the model that we made. Autodesk 360, CVEN250 1, open. Right, which you should see that we have our coordinate system, it's all correct. Key thing here is that we want to refine the selection set, because what happened is you're going to get all the roads and all of the stuff that we don't need. We don't need this existing transportation. We don't need any of these roads. We just want to make sure we have our water areas and our existing ground. Click OK. We open our model. Right. Notice that we have like this giant set, this giant polyline of the Brazos River. We don't need all of that. So what we're going to do is we're actually going to use the break command to kind of just trim this down a bit. All right, now we can go ahead and zoom extent. See, this is what we're kind of looking at. All right, now what we got to do is we got to change this from a 3D polyline to a 2D polyline. To do that, we're going to go to Modify, Design, Convert 3D to 2D. And we're going to select this one right here, press Enter. All right, now we're in a 2D polyline. Now from there, we can actually go ahead and go back to the Home tab, Alignment from Object. Go ahead and click our center line here, press Enter. That's the correct flow. It's flowing downwards towards the Gulf of Mexico. All right, you can name this whatever. I just named it flood map. Click that. Change this layer just for consistency purposes, because it's obviously not a road. We're gonna go ahead and go to water and then center for water center line. Okay. All right. Now notice that we have station numbers on our river now. All right. Up next, we're gonna go ahead and create a new layer. We call this cross section. Click on this little blue parallelogram to make it the current layer, right? Then we're going to use P-line, and we're just going to draw some lines going across this river. You kind of want one going across here. There's this road. Be careful not to put one on these tributary areas, as they have to be perpendicular to the flow of water. So here are my 1, 2, 3, 4, 5. One more for good measure. 6. All right. So here are my 6 polylines. Now we're going to go ahead and convert those into sample lines. So see here, select your alignment. Boom. Let's call these cross sections. And everything should still be the same. Just changing the name. Go down here, select existing polylines. Let's go ahead and select the ones that we just created. All right, click enter. Boom. How do we know something happened? Let's exit out of here. And you should see station numbers on your cross sections. All right, so now we're done with this portion right here of Civil 3D. Now we need to go ahead and export it to HEC-RAS. So we go to Output, Export to HEC-RAS, right? Make sure that we have everything. Our surface is the existing ground from Infoworks, the alignment that we created with that center line, the cross section that we made. Let's give it a river name, Brazos. We don't have to check this off. We didn't select the banks. So we go to Export. It's best to have a folder already ready to go with all this stuff in here. So just gonna reuse this. Okay. Right, now we're done with this. Now we're gonna go ahead and open up HEC-RAS. All right, we're gonna open up a new project. Let's give it a name. I've already kind of used up every name I could think of. Brazos HEC 3. All right, we want to go ahead and find a directory to put this all in. Let's put it just in here. As you can see, I kind of already made a bunch. Just give it a title name. Okay. Okay to that. Right. First thing we want to do is we want to edit our geometry. 2 ways we can do this. We can click the button here. or we can go to edit in geometric data. I like clicking the button, file, import our geometry data, GIS format, right? And there you go, boom, it's the first thing that comes up right here. If not, just search for it. Go ahead and click next, finish import data, boom. Notice how we got our, now for some people, it may not show all the cross sections. And if it doesn't, then I'll give you guys some instructions on what to do. But if you guys get this far, you're looking pretty good right now. So then from here, we want to go to our table, our Manning and K values. Going to select all these cells, set value 0.040. Once you take water resources, you'll know what these numbers value means. These are just generic values. Let's click OK. Then we want to save our geometric data. Let's call it Brazos River Geo. Okay. All right, we're done with this portion here. We can exit out of there. Up next is we need to do the steady flow data. Right, we need to change this to 2 profiles. Then after that, our reach boundary conditions, we want to change this to 0.05. Click OK. Right. And then what we want to do is, for good practice, we want to edit the profile names. You don't have to. It's just for good practice. Let's change this to 100 year. Let's change this to 500 year. So click OK. Right, and these 2 values here will be given to you by hydrological data. So these are just plugin values that we'll use for this lab. 2000 and 4000. Apply the data. Save the flow data as. Just give it the same thing. Brazos River flow. Click OK. Okay. Exit out of there. Right. Now we need a simulation. So we look at the guy that's running away, do some flood mapping, and then we compute it. Right, notice that I got a bunch of errors here. That's fine. All right, we go to our river data here. This is one of the things that I wanted you guys to screenshot. All right, then finally we go to our GIS tool, RAS mapper. Right. First thing we want to do is create a new RAS terrain. No. Right. We're going to go back into that lab that we got, go to terrain, find this bad boy right here and bring it in. Yes, we want to use the geospatial data. Create. Close that. Right. Notice that we have our surface data right here now. Let's go to geometries. Let's go ahead and turn those on so we can see our river and our cross sections. Right, and then we want to go ahead and calculate our areas. Let's go ahead and add our 100 year, 500 year. Close that. Compute and update. Oh, we ran into an error. Ran into another error. So we keep getting errors here. This is how far you've gotten. From here, you can export the actual things into the shapefile. But let's say you didn't get this far, like I did. So we're going to go ahead and close this. Going to go to File, Open Project. And we're going to open CVEN250 project. Click OK. And everything here is pretty much already done for you. We have this screenshot here that you may use. Open up the RAS mapper. As you can see, it has everything already completed for you. All you need to do now is just export these layer files. Save them as the 100 year. Same thing, save this one, export it to shapefile as the 500 year. All right, and once we're done there, you can take a screenshot of this or a screenshot of yours, whichever one, and you're done with HEC-RAS. All you have to do now is just import the file into Civil 3D. So now we're back at Civil 3D. So once again, the key thing here is that we want to import our shapefile. So we use map import. Locate where you have your shapefile at. Make sure that if you can't find it, make sure that you're using the Esri shapefile and it should come up. Let's click OK. All right, key thing here, we want to make sure that we're in the correct coordinate system. This is not the correct coordinate system. This is Texas 83 Central meters, and we need US foot. So we need to find that. Go to search Texas right here. Oops. And 883 Central foot, select that. Import polygons as closed polylines. Import it there, and boom, now we have our 100 year. To switch color without having to select the object, it's a layer. So you come in here and just change it to red from here. Works a lot better than clicking on it. So we do map import again. Select our 500 year. Same thing. Import polygons as closed polylines. All right, same thing that we want to do here. We want to go ahead and change the color. I said I wanted cyan. There we go. All right, and you could change the plane width and whatnot of it. As you can see, it kind of overextends our boundary, but that's fine. For the purposes of this lab, this is fine for me. All right, we go to our Tmu Layout. Double click in here, grab in here. You want to go ahead and lock it. And then change this to maybe 1 to 250. Yep. Change it to 1 to 250. And then let's go ahead and add our scale bar. North arrow's already been included there. All right, and that's it. You're done. If you guys have any questions, let me know.